Welcome to ClickMyProject.com. Let me discuss about the project impacts of deployment strategies on localization performance in underwater acoustic sensor networks. Let me discuss about the abstract of the project. Underwater network consists of a variable number of sensors and vehicles that are deployed to perform collaborative monitoring tasks over a given area. Underwater acoustic networks are very unique and can be deployed for commercial and military applications. The research of UANS attracts increasing attention in recent years. Here, no deployment and localization performed for three-dimensional environment. Implemented different deployment schemes such as random deployment, cube deployment, and regular tetrahedron deployment schemes. Among the various deployment strategy, regular tetrahedron deployment scheme outperform. Their performance have been evaluated in terms of reducing localization error and increasing localization ratio without changing the average number of neighboring anchor nodes, and maintain maximum network connectivity. For this estimation of the performance, which is implemented by received signal strength indicator technique, which utilizes the relationship between the transmitted signal power and received power. Based on the multilateration method, can estimate the coordinates of the ordinary nodes with the known location of anchor nodes. The performance of deployment scheme computed maximum localization ratio represented the localization of more number of ordinary nodes. Let me discuss about the flow diagram for our process. Initially, deploy anchor nodes and ordinary nodes in randomized manner, either the random deployment scheme, cube deployment scheme, or else regular tetrahedron deployment scheme. In the multilateral method, the multilateral method is used to calculate coordinates of ordinary nodes. The localization errors of three deployment schemes increase with the increase of number of sensor nodes. This is because the RSSI method uses the relationship between transmitted power and received power of wireless signals to express the distance between two communicating road nodes. The longer the distance between two communication nodes, the larger the localization error caused by the RSSI based localization technique. In the implement of random deployment scheme, the random deployment scheme outperforms the random deployment scheme. In the random deployment scheme, anchor nodes are deployed randomly in a three-dimensional monitored region. Ordinary nodes in all the three deployment schemes above the deployed randomly in the three-dimensional monitored space. If no prior knowledge of the monitored region is available, or deterministic deployment sensor is very risky or infeasible, random deployment often becomes the only option. Next, in the implementation of cube deployment scheme. In the cube deployment scheme, anchor nodes are deployed at the vertices of the pre-positioned space-filling cubes, whereas in the regular tetrahedron deployment scheme, anchor nodes are deployed at the vertices of some pre-positioned regular tetrahedrons. Among all kinds of regular polyhedrons, the cube is only space-filling regular polyhedron. Next, implement the regular tetrahedron deployment scheme. The regular tetrahedron deployment scheme can achieve higher localization accuracy while maintaining good localization ratio, the average number of sensor nodes, and network connectivity. In the regular tetrahedron deployment scheme, anchor nodes are deployed at the vertices of some pre-positioned regular tetrahedrons. The regular tetrahedron deployment scheme has smaller localization error than the random deployment scheme and the cube deployment scheme in general. Finally, we calculated the performance evaluation. Performance evaluation of the three deployment schemes are evaluated. Localization ratio is the ratio of the number of localized ordinary nodes to the total number of ordinary nodes. Obviously, the higher the localization ratio is, the more ordinary nodes can be localized. Localization error can be estimated by the average distance between the estimated coordinates and the real coordinates. Clearly, the smaller the localization error is, the better the localization result will be. Average number of neighboring anchor nodes is the ratio of the number of sensor nodes that can communicate with anchor nodes to the total number of sensor nodes. Network connectivity is the ratio of the number of sensor nodes that can communicate with other sensor nodes to the total number of sensor nodes, which can be computed. The performance of regular tetrahedron deployment scheme is slightly better than that of the other two schemes. Let me discuss about the running procedure for our process. Select the main file.m file in the current folder, right click the file and run for executing this process. This is the main window for the impacts of deployment strategies on localization performance in underwater acoustic sensor networks. By pressing the three-dimensional surface, we perform the three-dimensional surface based on the cube deployment. By pressing the deploy bottom node button, we perform the deployment of the bottom node. Here the number of deployed bottom node is 7. By pressing the deploy underwater node, we perform the deployment of underwater. Here the number of underwater node is 17. By pressing the deploy AUV, we perform the deployment of the AUV. Here the number of AUV is 5. By pressing the deploy sync node, we perform the deploy the sync node location. Here number of sync node is 9. Now the network deployment is performed. By pressing the select the cube deployment, we perform the cube deployment operation. Here the bottom node and also anchor node are deployed. By select the 1 cube unit, we perform the 1 cube unit. And this is the random deployment scheme. And by selecting the one regular tetrahedron deployment, this is the one regular tetrahedron deployment where anchor nodes and also ordinate nodes are deployed. Now we perform the topology operation. By pressing the random deployment, we perform the random deployment operation. And by pressing the we have to estimate the multilateration method button. And here we perform the multilateration where anchor node, ordinate nodes and also estimated locations are performed. Pressing the random deployment button, perform the random deployment operation. This is the random deployment in three-dimensional environment. And here the localization ratio, localization error, average neighboring node, network connectivity is performed. By pressing the cube deployment button, we perform the cube deployment operation for anchor node and also the normal nodes. Here localization ratio, localization error, average neighboring node and network connectivity will be performed. Pressing the tetrahedron deployment, we perform the tetrahedron operation. We obtain the localization ratio, localization error, average neighboring node and network connectivity for tetrahedron deployment scheme. Now by pressing the next button, we can perform the performance. This is the performance graph. By selecting the localization ratio, we estimate the localization for random deployment, estimating the localization ratio for cube deployment, estimating the localization ratio for tetrahedron deployment. And now select the anchor node percentage. By selecting the 6.75%, we got the graph for localization ratio, anchor node percentage 6.75%. Selecting the 16%, we got graph localization ratio, anchor node percentage for 16%. By selecting the 20%, we got the localization ratio, anchor node percentage for 20%. Now we have to estimate the localization error. Estimating localization error for random deployment, localization error for cube deployment and also estimating localization error for tetrahedron deployment. Now by selecting the anchor percentage 6.75%, we got the localization error, and likewise 16% we got the localization error graph, and also by 20% we got the localization error. And by pressing the average number of neighboring nodes, estimate the average number of cube deployment and average number of tetrahedron deployment. And selecting the 6.75% for average number of neighboring nodes, 16% as well as 20%. Selecting the network connectivity, estimating network connectivity for random deployment, for cube deployment, connectivity for tetrahedron deployment, we got the 6.75% anchor node percentage, we got the network connectivity graph, and also 16% we got the network connectivity graph, also 20% we got the network connectivity graph. Finally we derive the tetrahedron deployment scheme outperform both random deployment also cube deployment based on the multilateration method. Thank you.